This is your limit definition of a derivative and tangent and normal lines help. This is your daily grade. I just pulled a few from each section or one from each section to help you have something to go off of as you work on this. Okay, number 2, in the first section, we actually did this in class, but I wanted to go over it one more time. It says to find the derivative of the function f prime of x using the limit definition. So in order to do that, you have to first remember that the definition of a first derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so we need to find, we know what f of x is, that's given in the function, or given in the problem, it is just the function. We need to define f of x plus h. So that's simply replacing every x in the problem with the quantity x plus h. And we get this nice 3 over x plus h minus 1. So I'm going to then sub into my derivative definition. So I have the limit as h approaches 0. F of x plus h is this nice little quantity, 3 over x plus h minus 1, minus, because that's what my formula is, the function 3 over x minus 1 all over h. Now we need to go through our list of how we evaluate these. The first thing we always check is it a direct substitution? Can I just sub in the value into the function because that value is in the domain of the function? Well, in this case it is not, because 0 will make our overall denominator 0 and will not, we cannot do that. So we can't have an undefined value. So then our next option is, can we factor and then simplify something out? And that unfortunately is not the case here either. There's nothing that I can factor and simplify. So we move on to our next option, which is algebraic manipulation. Is there something algebraically that I can do to this to maybe evaluate the limit as a direct substitution? And the answer to that is yes. It is a complex fraction, so I can get this as one fraction, get the numerator as one fraction, and keep flip change to simplify and hopefully be able to evaluate this with direct substitution. So I'm going to multiply this left term by x minus 1 to get that common denominator, and the right term by x plus h minus 1. Okay? So then I can say that the limit as h approaches 0, I'm going to do some distributive property, 3x minus 3 minus parenthesis. If you don't put those parentheses, you're not going to distribute all the way across. So then I'm going to distribute this 3x plus 3h minus 3 all over that common denominator of x plus h minus 1 and x minus 1. Okay? All over h. So now I need to do a little bit of algebra cleanup. I have 3x minus 3x, which goes to 0, a negative 3 minus a negative 3, which goes to 0, which leaves me with a negative 3h. Okay, so then I have the limit as h approaches 0 of negative 3h over x plus h minus 1, x minus 1 all over h. Now I am ready to keep flip change this. So this fraction is going to stay the same. I'm going to flip the denominator and change division to multiplication. Please do not write this as 1 over h. It is already do not write this as h over 1. It's already h over 1. So when we flip it, we should be multiplying by 1 over h. Okay, so then I have the limit as h approaches 0 of negative 3h over x plus h minus 1, x minus 1 times 1 over h. And this makes me feel good because now I have simplified out the problem that I was having with direct substitution. So now when I simplify, I get a value that does allow 0 to be in the domain of that function. Remember that when we were talking about a limit as h approaches 0, that value has no bearing on x. So I can absolutely replace h right here with 0. So we can now do a direct substitution, negative 3 x plus 0 minus 1 and x minus 1. And I can do just a little bit of cleanup because these are both x minus 1, and I can write that as 3 over x minus 1 quantity squared. Okay? And then that's my first derivative. Okay, so now in the second section, it says to find the slope of a tangent line to the given function at the indicated point. So remember that the limit definition is still the same. The only difference is when we're talking about f prime of a, we've already chosen the point. So this is very specific. When we are specific, we're then talking about the slope of the tangent line at that specific point. Okay, so that f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so remember that to get the slope of the tangent line is simply evaluating the derivative at the point of tangency. Okay, so I need to find my pieces, so I'm going to find f of a, which would be 3 minus, so remember this is a, the x coordinate of your point, 3 minus 2 times negative 1. Now we should expect to get 5 out because that's its ordered pair. That's the y that is in the ordered pair. So you don't really have to show this. I just wanted to point out that you should expect that to happen. So then I have f of a plus h. So my a value again is that negative 1. So I have 3 minus 2 times negative 1 plus h. So I have 3, a negative 2 times negative 1 is positive 2, and negative 2 times h is negative 2h, which gives me 3 plus 2 is 5 minus 2h. Okay? So now I can plug into my formula. I have f prime at a, which is my m tan, right? The slope of the tangent line at this point, the limit as h approaches 0. I know that f of a plus h is right here, 5 minus 2h, minus, because that's my formula, f of a is 5 all over h. So I have the limit as h approaches 0. 5 minus 5, of course, goes to 0, and I'm left with negative 2h over h. And again, those h's simplify out and leave me the limit as h approaches 0 of negative 2. And we, of course, know that the limit of a constant is the constant of the limit. So I have negative 2. And that's going to be my m tan. And as we talked about in class, this should make complete sense, because when we are talking about a linear function, at any point, the slope is going to be the same. Okay? So because it is a constant rate of change. So our instantaneous rate of change and our constant rate of change are going to be the same, because the slope along that tangent line everywhere, the slope along a linear function is always constant. Okay, so now we have the slope and we have a point, and we can absolutely write the equation of a line. So the equation of your tangent line is simply y equals mx plus b, if you so choose to do it this way. So I have 5 equals negative 2 times negative 1 plus b. So I have 5 equals 2 plus b. So set 3 is equal to b. Okay? So that means I have y equals negative 2x plus 3, and that is the equation of my tangent line. Okay? The next section asks you to do the same thing, except it also talks about the normal line. We didn't talk about this a lot in class, so just to clarify, the normal line is simply the equation of a line that is perpendicular to the tangent line at the point of tangency. Okay, so once I have the slope for the tangent line, so I'm going to do everything exactly like I did in the previous problem, and once I find the slope for the tangent line, I can take the opposite reciprocal, and then I have the slope for the normal line, and the normal and tangent line go through the same point. Okay, so when I find g prime of a, that's going to be the limit as h approaches 0 of g of a plus h minus g of a all over h. So I need to find my pieces. So of course we know that g of 2 is 5. It's given in the ordered pair. And g of 2 plus h is 2 plus h quantity squared plus 1. So remember the shortcut for expanding this: square the first term twice the product, square the second term, and then I get this nice quadratic of 5 plus 4h plus h squared. So I'm ready to plug into my definition. So I have g prime of a is equal to the limit as h approaches 0. G of a plus h we defined as 5 plus 4h plus h squared minus g of a we defined as 5 all over h. So minor algebra cleanup, we know that 5 minus 5 is going to go to 0. So I have the limit as h approaches 0 of 4h plus h squared over h. Again, those h's will simplify out, which is what we expect to happen. So I have the limit as h approaches 0 of 4 plus h. And then, of course, we know that the limit of a constant is the constant, and the limit as this approaches 0 is going to be 0. So that we have g prime of a is equal to 4. And remember that this is the slope of the tangent line. So when I want to write the equation of the tangent line, this time I'm going to use point slope formula. So I have y minus y1, which is 5, equals my slope of 4 times x minus x sub 1, which is 2. So I have y minus 5 is equal to 4x minus 8. Add 5 to both sides, and I get y is equal to 4x minus 3. Now remember that if m tan is 4, then m normal or m perpendicular is going to be negative 1 over 4. So when I want to write the equation of the normal line, I have y minus 5 is equal to now negative 1 over 4 times x minus 2. So I have y minus 5 is equal to negative 1/4 x plus 1/2. So I'm going to add 5 to both sides, and I get y is equal to negative 1/4 x plus 11 over 2. Okay? So now I have my tangent line and I have my normal line. The next section says, given f prime, determine f of x. So we're kind of going to work backwards. So we're already plugged in to the equation, to the limit definition, and we want to go backwards. So what you have to remember is that this is f of x plus h. This is f of x. So we already know what f of x is. It's just the second part of the equation. So f of x is just simply 2 square root of x. Now it's not negative 2 because remember the minus sign is part of our definition. Okay? In the next section we have the same thing, except we're talking about a specific value of a. So we already know the point of tangency and we're plugging that in. So this would actually end up being m tan, right? So the equation is still the same. So the limit of the function f prime of a is simply f of a plus h minus f of a. So this is a value because we've already evaluated. We plugged a number in and got a value. Okay, so don't forget that limit I did over h. Okay, so this is the value of the function with a plus h. So I know my a value is 1. And remember that we replace a plus h for every x. So that means this whole quantity used to be an x. So f of x is just simply 5 minus 3x. Okay? And that's all I have for you.